are some of the lessons you'll need for this week. The first one we're going to start with is called Compare to Solve Problems. So what we're going to be doing is taking a look at this assignment and going through a few of the examples so that you'll be ready to go to take it out on your own. So basically we are working on comparing parts of a problem to be able to come up with a solution. So the first part of this talks about additive comparisons. So when you have an additive comparison, it means you're using addition or subtraction to compare. Another kind of comparison is a multiplicative comparison, and that uses multiplication or division to compare. There's some different language that's used for each one. So for additive comparisons, it's words like how much more, how many more, and how much less. If it's a multiplicative comparison, you see how many times more or how many times greater. So those are some of the clue words you can look for. So for example 1, it says Brian has been to a water park 4 times. Sarah has been to the water park 3 times as many times as Brian. How many times has Sarah been to the water park? And they want us to write an equation to find out the unknown number. So we're going to start with Brian, and this is what they have written for you right here. They have 4 times something is equal to S, and they use the S to be Sarah. So we're going to take the information that we know from the problem, and it tells us we're searching for the unknown here, which is S and Sarah's number. In the original problem, it shows us that Brian has been 4 times and Sarah has been 3 times as many. So what we're going to put in there is that 3, because we need to figure out what that is, and this is a multiplicative comparison. So in order to solve this, we're going to be drawing a picture. Okay, so draw a picture to show 3 times as many as 4. Okay, so we're going to start with groups of 4. And if we have 3 times as many, we need to make sure we make 3 groups of 4. So here I am drawing our 3 groups of 4, because that represents Sarah's, right? Because Brian is just 1 group of 4, Sarah is 3 times that many. So when we do that, we are doing 4 times 3, which is equal to 12. So we know now, if we do this problem, that 4 times 3 is equal to S, or Sarah's number. So Sarah has gone 12 times, and you can use that information to fill out the blanks at the bottom of the page. On the back, we have another example. So for the one on the back, it says Jess has 18 baseball cards. She has 6 times as many baseball cards as Max. How many baseball cards does Max have? Now this is a little bit different equation. So we know the total, we know how many Jess has, and we know that that is 6 times as many as Max. So we're going to start with our blank for Max times 6 is equal to 18, right? I'm just filling in this information on this line. So in order to find out this missing factor, we need to be able to do some math with the 2 numbers that we have. Now, the only 2 ways to make a larger number are addition and multiplication. So if we think about this kind of like a fact family, I'm going to draw it out like a fact family here. We know that the answer to a multiplication problem is the biggest number that we can make. So if this is a multiplication and division fact family, 18 is going to go up here on the top, and we know one of the corners. So ultimately what we're trying to do is figure out what this missing corner is, right? To figure out how many Max has. So they ask us also to draw 6 equal groups of squares. So we're going to take this number, this 18, because we know that's how many we have all together, and we're going to put it in groups of 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I have taken this number 18 and I've split it up into groups of 6. How many groups of 6 did I just make? Well, I made 3 groups of 6. The same way, if we use our fact family to help us find the answer, we'd be able to write 2 multiplication problems. 6 times, we're going to call this m because we're trying to find for Max, that's our variable. 6 times m is equal to 18, right? We could also do m times 6 is equal to 18. And we could write 2 division problems, starting with the largest number. We could do 18 divided by m is equal to 6. Or we could do 18 divided by 6 is equal to m. If we're trying to find this missing corner, this is the one that we're going to do, right? And that's exactly what we did. We took 18 and we split it up into groups of 6, and then we looked at how many groups did we make. Well, we made 3 groups, right? So in answering our question here, how many squares are in each group? Well, I didn't really make these squares, but if you imagine that they're squares, we have 6 squares in each group. So you've got your answer to the problem right here. So m is equal to 3. So Max has 3 groups of 6, right? All right, at the bottom of this page, we have one more guided practice problem. And I think I'm going to need to erase to make us some room here. So let's see the last problem on that page. Sue has 3 times as many beads as Joe. Joe has 8 beads. How many beads does Sue have? So we know we're starting with what Joe has, and we know that Sue has 3 times more than that. So if we know that Joe has 8, and we know that Sue has 3 times that many, remember this is Joe, this is going to tell us how many beads. So this is Joe, and this is how many more times Sue has. Let's go ahead and solve this problem. That would be 3 times something is equal to the beads. Well, we're going to be making sure that we multiply by 8 because that's how many Joe had. So we know that 3 times 8 is 24. So that is how many beads Sue had, because Joe had 8, right? I can draw it as a picture if I want to. So here's the 8 that Joe had. Sue has 3 times that many. So I have to draw 3 groups of 8. So this is going to be Sue, because Sue has 3 times as many. Altogether, Sue has 24. All right? If you have questions with this or need help, you can get me at mvaw123@gmail.com or on Class Dojo. Good luck!